Today we are gonna talk about proteins, especially enzyme delivery carrier graphene oxide. First of all, what is GO called graphene oxide? Graphene oxide is a highly oxidized form of chemically modified graphene. It is produced by sonication or other dispersion methods to produce monolayer material, typically in aqueous suspension. Graphene oxide structure consists of single atomic carbon sheet with hydroxyl and epoxide groups above and below each plane, and carbonyl and carboxyl functional group attached to the edge of the graphene sheet. So, due to functional groups, the edge of the graphene oxide sheets are hydrophilic, whereas the basal plane is hydrophobic, and the result is an amphiphilic giant shell-like molecule. And now, we may have questions. Why we use GO for biological carrier? It's due to their in vitro and in vivo biocompatibility, low impact on the environment, structural features, large surface area and low cost, and fossil chemical processing. GO-based materials have potential application in drug delivery and gene delivery and near-infrared photothermal treatment for cancer and Alzheimer's disease. The application of materials to the organism for medical purpose leads to exposure of proteins, and the interaction depends very much on the properties of used materials, such as surface energy, surface charge, and hydrophobicity. So, in GO case, upon exposure, the surface of GO interact with proteins of biological, fluid-like serum or blood plasma, which significantly affect the biological characteristics of GO. For example, surface-bound proteins enhance specific cellular uptakes and activate intracellular signaling pathway. It represents the first possibility of the formation of protein graphene oxide complexes. Second possibility represents purposefully preparing a novel complex between protein and GO, because significant portion of GO-based application is based on the molecular interaction between GO and proteins. According to this possibility, immobilization of proteins on solid substrate improves their performances. The GO protein complex shows several advantages, such as unique biological chemical properties, higher biocompatibility and stability, ability of conjugation to target receptor, and cell internalization. Then, how to conjugate graphene oxide and protein or enzyme? There are two ways, non-covalent interaction and covalent interaction. First method is non-covalent interaction and same as physical adsorption. Mechanisms of protein absorption on GO is a kind of non-covalent self-assembly, including van der Waals first, hydrophobic, electrostatic, and pi-pi stacking interaction. Graphene oxide consists of sp2 hybridized honeycomb carbon lattice, so hydrophobic regions of the protein interact with the carbon lattice predominantly. The hydrophobic interaction between GO and protein strongly depends on electron density and geometry of protein molecule, as lower electron density decreases hydrophobic interaction. Also, hydrogen bond between proteins and side group of GO suffers surface adhesion. The van der Waals force also influence aspect, and increase in unfunctionalized regions on the surface increase van der Waals interaction on GO. Last first is pi-pi stacking interaction. As you can see, the basal plane of the GO enriched with pi electrons. In picture A, you can see each carbon atom of GO bonded with 3 adjacent carbon atoms with sp2 hybridized orbitals forming sigma bonds, and the rest of the electrons on p atomic orbitals are delocalized or over the basal plane of the GO sheet, forming a pi bond. This makes possible for GO to interact with proteins through pi-pi interaction. Next method is covalent interaction. The enriched reactive oxygen functional group of GO provide a good solid substrate for protein immobilization through covalent bonding. Chemical reaction is occur between side groups of amino acid residues located on the protein surface and functionalized group available on GO. GO can be activated before binding proteins, usually by introducing electrophilic functionalities on the surface. Several functional groups can be modified on GO by chemical modification such as ketosan, folic acid, and polyethylene glycol. There are advantages and disadvantages in covalent interaction. It has highest binding strength between GO and protein. However, chemical immobilization results straight modification, leading to decrease of protein functionality or enzymatic activity. but it can overcome by cross-linking molecule. Between protein and GO, appropriate cross-linking molecule prevent this, and cross-linking molecule bind to GO through hydrophobic and pi-pi interaction, and covalently bind to protein. But most of the covalent immobilization methods are non-specific. So we can apply click chemistry for specific conjugation. Let's figure out what is click chemistry through antibodies example. According to oxide alkene click chemistry, GO can be efficiently functionalized by linear polymer, various amino acid, and aliphatic chains for specific conjugation. Especially for enzymes, enzyme immobilization onto GO are result of the synergetic effect of different interaction. For example, for chymotrypsin, GO strongly inhibit activity of chymotrypsin due to coexistence of anionic, hydrophobic, and pi-pi stacking interaction. The interaction between enzyme and GO should be a comprehensive result of several attractive and repulsive interactions and exact force or driving force. For example, for HRP and lysozyme, they are only immobilized through electrostatic interaction if the pH level is below the isoelectric point. And thank you for watching.